Welcome to the deep dive. Today, we're diving headfirst into a book that's, well, it's not just for designers, is it?
Not at all.
It's for anyone who's ever, wrestled with a door handle or just stared blankly at a remote control. Don Norman's The Design of Everyday Things.
Yeah, Tim Brown from IDEO, he really put it well, called it part operating manual for designers and part manifesto.
That's a great description.
It really is. And the book, even though it's been around a while, it still feels completely relevant today.
Right.
Don Norman, co-founder of Nielsen Norman Group, he just has this amazing mix of engineering background and deep psychological insight.
He really gets into the why, doesn't he? Why some things just work and others are infuriating.
Exactly. And he's written other key books too, like Emotional Design, The Design of Future Things, Living with Complexity. Clearly, this is his thing, understanding how we interact with stuff.
Absolutely. And that's really our mission today, to kind of pull out the core wisdom from Norman's work, get to the heart of how everyday things are designed, or, let's be honest,
How they should be designed.
right, why some things feel intuitive and others feel like, you're fighting them.
Our goal here is really to give you, the listener, a better lens, a way to look at the design of the world around you differently. Doesn't matter if you're a designer yourself or just, well, living your life.
Understanding these principles can be surprisingly revealing.
It really can.
Okay, so let's start unpacking it. Norman kicks off with this fundamental challenge, boiling down to two really crucial ideas: discoverability and understanding.
Yeah, discoverability and understanding. They sound simple enough,
They do.
but it's kind of staggering how many designs just stumble right there.
So what's the core difference?
Well, discoverability is basically,
Mhm.
can you figure out what's possible? Where do you need to act? How do you act? Is it obvious?
Okay.
Understanding is more about, okay, what does it all mean? How is this thing supposed to be used? What do these buttons or levers actually do?
That moment of panic with a new gadget, wondering where the power button is.
Exactly. Prime example. That's discoverability failing you. Good design should make the main functions just apparent right away.
He then brings in these concepts called gulfs. The gulf of execution and the gulf of evaluation. Can you break those down a bit?
Sure. So the gulf of execution, that's the gap between what you want to do in your head and the actual physical steps you need to take with the device or system to make it
It's
happen.
translating intention into action.
Precisely. Then the gulf of evaluation is sort of the flip side. It's the gap between what the system shows you, the feedback it gives, and how easily you can figure out if your action actually worked. Did you achieve your goal?
And good design should.
Good design bridges those gulfs. It makes the interaction feel seamless, you know how to act, and you know if it worked. No guesswork needed.
Now, I'm really interested in those 7 stages of action he outlines. Could you maybe walk us through an example, make it concrete?
Yeah, absolutely. It sounds complex, but we do it all the time. Let's say your goal is simple. Make a cup of tea. That's stage 1, the goal. Stage 2, plan. You think, okay, need hot water, tea bag, mug. Stage 3, specify, walk to kettle, fill it, switch it on. Stage 4, perform. Yeah. You actually do those things.
Physical actions.
Then stage 5, perceive. You see the kettle boiling. Here, maybe stage 6, interpret. You realize, water's ready.
Got it.
And finally, stage 7, compare. You check the outcome against your goal. Do I have hot water for tea? Yes. Goal achieved. We cycle through this constantly, often super fast, even for tiny tasks.
And so much of that is subconscious, isn't it? He makes that point about knowing a friend's number instantly versus, say, dredging up some historical fact.
Exactly. A huge amount of our daily behavior is just automatic, learned skills running on autopilot.
Yeah.
It doesn't take much conscious thought once we've done something enough times.
That difference between recalling a familiar number, declarative memory, right?
Right. And needing deliberate effort to pull out other info, it really shows how our memory works in different modes, which means, designers should try to tap into existing habits when they can. Don't make us learn something completely new if an old pattern works.
He also discusses 3 levels of processing: visceral, behavioral, and reflective. How do those fit into our experience with design?
Okay, so visceral is that immediate gut reaction, the first impression. Aesthetics, feel.
Love at first sight, maybe? Or revulsion?
Kind of, yeah.
Yeah.
Behavioral is the doing part, the actual use, the learned skills, mostly subconscious, like driving a car once you're experienced,
Muscle memory.
basically. And reflective is the conscious thought part, how we interpret the product, our memories associated with it, how it makes us feel about ourselves.
So a truly great design needs all 3.
Norman argues, yes. Enjoyment comes from engaging positively on all levels. It looks good, visceral, it's easy and satisfying to use, behavioral, and maybe it makes you feel smart or fits your self-image, reflective. That's the sweet spot.
Which leads to how we, as users, create these mental pictures, these conceptual models of how things operate. But our models don't always match the designer's intention, do they?
No, definitely not. And that's where things get tricky. There's the designer's model, how they intended it to work. There's the user's model, your personal understanding, often simplified or maybe even wrong.
Okay.
And then there's what Norman calls the system image. That's everything the product itself communicates as physical form, the labels, the buttons, any instructions. The system image is what bridges the gap, ideally guiding your user model to match the designer's model.
So a confusing interface means a poor system image.
Often, yes. Like that frustrating refrigerator example he uses where the controls for the fridge and freezer sections are just baffling. You can't build a clear mental model because the system image itself is misleading. That's a design failure. The system image has to clearly communicate function.
That makes total sense. Okay, let's shift to this idea of knowledge in the head and in the world. It's not all about pure memory, is it?
Not even close. Norman's point is crucial. We can act precisely even with fuzzy knowledge in our heads because we rely so much on cues and information present in the environment, knowledge in the world.
Labels, instructions.
Exactly. But also things like the physical arrangement of controls, sounds, even cultural conventions. It all guides our actions.
He distinguishes between knowledge of facts we recall and knowledge how skills we have.
Right. And the world around us is just full of these external memory aids, these signifiers. Think about simple things like putting your keys in a specific bowl by the door.
So you don't have to remember where they are, you just know where to look.
Precisely. Or sticky notes. Or calendar reminders. They offload the cognitive burden. He uses that great example of the old French coins.
Ah, yes, they were hard to tell apart at first.
Yeah, because they were similar sizes. People made mistakes until they learned to focus on the numbers printed on them, a feature in the world that helped distinguish them. It shows how we adapt to use the available external cues. So designers need to provide those cues clearly.
And constraints help too, right? Like doing a crossword puzzle, each letter you get right limits the options for the others.
Absolutely. Constraints are incredibly helpful because they narrow the possibilities. They guide us without requiring us to hold everything in our heads. This is super important given, the limits of our short-term memory.
Which can only hold a few things at once.
Right. And while long-term memory is vast, getting stuff in and out takes effort. Constraints make things easier.
He gives that open sesame example versus open barley.
Open Sim Sim, actually, but yeah, from Alibaba. Open Sim Sim is memorable. It has a certain rhythm. It's distinctive. Open barley is just random, arbitrary.
Harder to remember.
Much harder. It shows why meaningful structure is so vital. If you need users to remember something, make it meaningful, not arbitrary. Which naturally leads us to passwords.
Oh boy. Passwords. It feels like they're designed against human memory sometimes.
Well, that's the conflict, isn't it? Security experts want complexity, frequent changes, things that are inherently hard for us to manage reliably.
So we write them down on sticky notes.
Which defeats the purpose. It's a classic case of designing for the system's security needs without fully accounting for the user's cognitive limitations. People find workarounds, often insecure ones.
But some systems do work with memory. He mentioned pilots handling complex air traffic control instructions. How do they manage?
They use a combination of strategies, crucially relying on knowledge in the world. They write things down immediately. They enter data into their flight systems, that's external memory. They use standardized phrases, which chunk information meaningfully.
So they're not just relying on raw recall under pressure.
Not at all. They have robust procedures that acknowledge memory limits and leverage external aids and structure. Designers of any critical system should be thinking along those lines, build in the memory support.
So it's this constant trade-off, this balance between what we need to know in our heads and what the world can tell us.
Exactly. And when it comes to making that external information clear, natural mapping is just fundamental.
Okay, define natural mapping for us.
Natural mapping is when the relationship between a control and whatever it controls is intuitive, obvious. Think spatial correspondence. The layout of the controls matches the layout of the things they affect.
Like stove burners.
The classic example. A row of 4 knobs for 4 burners arranged in a square. That's usually bad mapping. You have to think or look or guess which knob controls which burner.
It should be obvious.
It really should.
Yeah.
A good natural mapping means you just know. If the knobs were arranged in the same square pattern as the burners, no mental gymnastics required. That struggle with a confusing remote or appliance. often a mapping problem.
So frustrating. Okay, let's pivot slightly. Constraints, discoverability, feedback, more key ingredients. Constraints limit actions, guiding us. He lists 4 types.
Yeah.
Physical, cultural, semantic, logical. Can you unpack those with examples?
Sure, physical constraints are, well, physical limits. A square peg won't fit in a round hole. A USB-A plug only goes in one way. Cultural constraints are learned conventions. Driving on a specific side of the road.
Yeah.
Knowing red usually means stop or danger, green means go. These are shared understandings within a culture.
Okay, semantic.
Semantic constraints rely on meaning. A windshield wiper control belongs on the steering column, not the floor, because of its meaning in the context of driving. You wouldn't put a saddle on a motorcycle facing backward.
Makes sense. And logical.
Logical constraints use reason. If there's only one piece left to a puzzle, it must go in the only remaining hole. Or if you have parts A and B, and A connects to the power, B must be the output. It's about deduction.
And thinking about cultural constraints again, like door handles, a lever suggests pulling down, a knob suggests turning, different expectations.
Exactly. Designers use these constraints, sometimes without even thinking about it, to guide us and prevent errors. Physical constraints are often the strongest.
Now, signifiers. They help with discoverability when the affordance, what you can do, isn't obvious.
Right. An affordance is a property of the object. A chair affords sitting. But you need a signifier to tell you how to use that affordance, especially if it's hidden or unclear.
Like that sink stopper example from the book.
Perfect example. The sink affords stopping the drain. But if there's no visible lever or button, no signifier, how do you know how to do it? You're stuck.
Doors, too.
Hmm?
The classic push-pull confusion.
The bane of existence. The door affords both pushing and pulling. But without a clear signifier, a flat plate usually means push. A handle usually means pull. We rely on trial and error. A good signifier eliminates that ambiguity. It tells you the correct action for the affordance. Designers need clear signifiers.
And light switches. Another everyday item, yet bad mapping causes chaos.
Oh yeah. A bank of identical switches on the wall. Which one controls which light? If the layout doesn't logically map to the room's lights, it's just guesswork every time.
Trial and error.
Exactly. Norman talks about designing his own switch plate with a little map of the room. That's extreme, but it highlights the importance of clear, natural mapping, even for simple things.
He also talks about forcing functions, like needing to press the brake to start your car. It forces a sequence.
Right. Forcing functions constrain actions to ensure safety or proper procedure. You must do step A before you can do step B. The car ignition is a perfect example.
Are there related ideas?
Yeah, interlocks preventing two things from happening at once. Lock-ins keeping an operation going until it's safe to stop, like a microwave door staying locked. And lockouts preventing entry into dangerous areas or states. They all use constraints to prevent errors.
Can forcing functions ever be annoying, though?
Oh, definitely. If they're poorly designed, unexpected, or seem arbitrary, they can be incredibly frustrating. They can feel overly restrictive. So designers have to use them carefully, make sure they're necessary, and ideally understandable.
Conventions, those cultural norms again. They help us, but can also block new ideas, like those destination control elevators initially.
Conventions are powerful because they set expectations. We learn how things usually work. But that means introducing something different, even if it's better or more efficient, can face resistance. People are used to the old way.
It's surprising how even designing a faucet can be tricky with mapping.
Especially single lever faucets. Which way is hot? Which is cold? Which way increases flow? Up, down, sideways. The mapping is often unclear or inconsistent between designs. It turns a simple task into a bit of a puzzle.
And finally, feedback. Absolutely crucial. We need to know if what we did actually worked.
Feedback closes the loop. It confirms your action or tells you the system's state. Without it, you're lost.
Like mashing an elevator button that gives no light or sound.
Exactly. That's Norman's point. Poor feedback can be worse than none. It leads to repeated, unnecessary actions and immense frustration. Good feedback is timely and informative. Conceptual models themselves act as feedback too, giving you a framework for understanding.
And feedback isn't just visual, right? Sound, touch.
Absolutely. The click of a keyboard, the rumble of an engine, these are all forms of feedback. The move to silent electric cars actually created a feedback problem for pedestrians, leading to rules about adding artificial sounds.
Interesting. And he mentions skeuomorphism, making digital things look like physical objects.
Yeah, like early ebook apps having page-turning animations or digital buttons looking raised. It uses familiar physical metaphors as a form of feedback to make new tech feel less alien. So clear, appropriate feedback is non-negotiable for good design.
Okay, this leads us right into a really powerful idea Norman stresses, blaming human error when accidents happen. He argues it's often bad design setting people up to fail.
This is such a critical point. Instead of just saying operator error, we need to look at the system. Was the interface confusing? Was the procedure flawed? Was the environment stressful?
Like the 3 Mile Island example he revisits.
Exactly. Initial reports blame the operators, but the control room design itself was a usability nightmare, making errors almost inevitable under pressure. Good design anticipates potential errors and tries to prevent them, or at least mitigate their consequences.
He also uses Reason's Swiss cheese model. Can you explain that?
It's a great visual. Imagine layers of defenses in a system, like slices of Swiss cheese. Each slice has holes, potential weaknesses, or flaws.
Okay.
An accident happens only when the holes in all the layers line up, allowing the hazard to get through. It shows that disasters usually aren't caused by one single failure, but by multiple factors coinciding. You need multiple layers of safety.
Norman then distinguishes between slips doing the wrong action unintentionally and mistakes having the wrong goal or plan to begin with, and he breaks slips down further.
Right. Slips are execution errors, often subconscious. A description similarity slip is grabbing the wrong milk carton because it looks like yours.
Got that.
A capture slip is when a familiar routine takes over inappropriately, like driving partway to work on a Saturday when you meant to go elsewhere. Mode errors happen when you think a device is in one mode, but is in another, like typing numbers when you thought you were typing letters.
Right, and memory lapse slips.
Simply forgetting to do something you intended to do, like forgetting to lock the door. Mistakes, on the other hand, are conscious. They come from bad planning, incorrect knowledge, or misinterpreting the situation.
And social pressure can play a role too, making people do things they know aren't quite right.
Definitely. Group dynamics, wanting to fit in, not wanting to challenge authority, these can all lead to poor decisions, overriding individual judgment. That scuba instructor example, rewarding people for aborting dives, is about actively fighting that pressure.
So the big takeaway is design should make errors easy to spot and fix. Feedback is key here.
Absolutely. And systems like Toyota's Judoka, stopping the line immediately when an error occurs, embody this. It's about catching errors early.
Like NASA's aviation safety reporting system too, learning without blaming.
Exactly. A non-punitive way to learn from errors. Norman notes memory lapse slips are the hardest to catch because, well, nothing happens. And we tend to rationalize mistakes after the fact, which doesn't help learning.
So what are the core principles for designing for error?
Okay, several key ones. First, understand the causes of potential errors in that specific context. Second, use sensibility checks. Does this input make sense? Third, make actions reversible, the power of undo.
Crucial.
4, make errors easy to spot and correct. 5th, help users complete tasks correctly, maybe with guidance or wizards. Also, consider interruptions. How easy is it to resume a task after being distracted? And design effective warning signals. Ultimately, use constraints to prevent errors where possible, confirm actions, and provide helpful, not cryptic, error messages.
This brings us nicely to design thinking. Norman really advocates for this human-centered approach. What's the gist?
Design thinking is basically a mindset and a process that puts human needs and experiences right at the center. It's about empathy, collaboration, and iteration to solve problems creatively.
He uses the double diamond model to illustrate the process.
Yeah, it's a useful visual. 2 diamonds. The first diamond is about finding the right problem. You start wide, exploring, discovering the issues, then you narrow down to define the specific problem you'll tackle.
Okay, first diamond, problem finding.
Second diamond is about finding the right solution. You again go wide, brainstorming, developing lots of potential solutions, then you narrow down again to test and deliver the best one. Diverge, converge, diverge, converge.
And the actual human-centered design process is that cycle. Observe, ideate, prototype, test.
Exactly. It's not linear, it's a loop. You observe users, understand their needs, brainstorm ideas, build quick prototypes, could be just sketches, test them with users, get feedback, refine, and repeat.
User research is vital throughout.
Absolutely. Observation, interviews, focus groups, surveys, A/B testing, whatever helps you understand a user and validate your ideas. It's iterative, always learning and refining.
He also mentions activity-centered design. How's that different?
It shifts the focus slightly. Instead of designing primarily around individual user characteristics, it focuses on the activities people need to perform. The design supports the structure of the activity itself. Think designing a cockpit around the activity of flying, not just for an average pilot.
But the whole design process has challenges, right? Conflicting needs like the buyer versus the
Oh,
user.
huge challenges. The person who buys the product might care most about price, while the person using it cares about ease of use. Business pressures cost, time to market, competitors always play a role.
And standardization.
Right. Standardization has benefits interoperability, easier learning, but it can also lock in subpar designs or stifle innovation. And designing for the average person often excludes many people at the extremes. Considering variability is crucial.
The QWERTY keyboard is the classic example of a standard that might not be optimal but is deeply entrenched.
Exactly. Changing standards is hard, though sometimes making things deliberately difficult serves a purpose, like security measures, or making a game challenging.
Okay, finally, let's touch on design in the world of business. He talks about technology life cycles and featureitis.
Ah, featureitis. The relentless adding of more and more features.
Why does it happen?
Several reasons. Customers ask for features. Competitors add features, so you feel you have to match them. In mature markets, adding features seems like a way to differentiate and encourage upgrades.
But more isn't always better.
Often it's worse. It leads to complexity, confusion, makes a product harder to learn and use. The dreaded feature creep.
He looks at how tech evolves phones, keyboards, contrasting radical and incremental innovation.
Right. Incremental innovation is common small improvements, refinements. Radical innovation is rare game-changing breakthroughs.
Like the video phone taking ages to catch on.
Exactly. Radical ideas, even if technically better, often face huge hurdles cost. Infrastructure, user acceptance, existing habits. Incremental changes are usually easier to adopt.
What's striking is how relevant his original 1988 principles still feel despite all the tech changes.
The core psychology hasn't changed that much. Discoverability, feedback, mapping these are still fundamental, whether you're designing a doorknob or an augmented reality interface.
Which he speculates about AR, embedded devices. How will they change interaction?
They'll change the how, definitely,
Mm-hmm.
but the need for good design principles remains. He also wades into that debate. Does tech make us smarter or dumber?
What's his take?
It's more nuanced. Technology changes the task we do. It offloads some cognitive work but demands new skills. When humans and tech collaborate well, like in freestyle chess where human plus AI beats AI alone, our overall capabilities are enhanced.
He also considers the future of books and brings up the moral side of design. Sustainability, avoiding feature overload.
Yeah, there's an ethical dimension. Are we designing things that are truly useful, usable, and sustainable? Or just adding to the noise and complexity? He emphasizes that ultimately, design is only successful if people actually buy, use, and enjoy the products. That's the bottom line.
So, wrapping up this deep dive, let's quickly recap those core principles we got from Norman.
Okay, the big ones. Discoverability. Can you find what to do? Understanding, do you know what it means? Natural mapping, do controls relate intuitively to effects? Feedback, does the system tell you what happened? Constraints, are you guided away from errors? And designing for error, anticipating mistakes, and making recovery easy.
And these aren't just for the pros, they're relevant for all of us every day interacting with the world.
Absolutely. Once you start noticing these things, you see design good and bad everywhere. It gives you a new way to look at why some things are a pleasure to use and others, well, aren't.
So here's a final thought for you to chew on. As tech gets more and more woven into our lives, AI, smart everything, how will these core design principles need to adapt or evolve? What current everyday design frustrations do you think might finally get solved by the next wave of innovation?
It's something to keep observing. Keep asking those questions about the things you interact with every day. Maybe even share your own design pet peeves or brilliant solutions you spot.